All right. Hi, I'm Sam Franz.
And I'm Zakia Sharp.
And we're going to take you on a ride to the next generation of education and innovation for the bioeconomy.
So in this presentation, we'll take you through the steps and natural progressions that has led to the formation of inclusive sustainable learning plans and innovative technologies in the context of a circular economy. So first, we will set the stage with defining sustainable development and its role in constructing holistic solutions. Next, we will focus on some of the barriers that have slowed our adoption of circular initiatives from an educational, research, and economic standpoint. Third, we will outline our proposed innovative technologies and its feasibility. And last, we will provide concrete tools and objectives that emphasize interdisciplinary collaboration and whole systems thinking to foster the next generation of sustainable products for mass adoption across all sectors. The Frontline Report states that sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This definition should remain a guiding principle in our understanding as it encapsulates the need to consider the interconnectedness of the social, economic, and environmental goals and the importance to push these three dimensions forward in tandem when formulating action plans. So the SDGs represent the understanding of the need of a holistic approach. The goals target the global challenges of poverty, social inequality, climate change, and governmental injustice. To formulate and implement strategies that facilitate progress on multiple fronts, it requires the collaboration of all stakeholders, which include local communities, government, academic institutions, and industries, both public and private. In brief, the Ellen MacArthur Foundation describes circular economies as a concept that promotes resiliency by ensuring all resources, inputs, and outputs are within a regenerative, closed-loop system. In other words, resiliency is the prime objective, and circular economy is a key motivator. So with this approach, and in combination with social justice and sustainable economic initiatives, we can create the needed paradigm shift to meet the SDGs. So the establishment of a linear economy has always been an inefficient and obsolete system, as its basis relies on the exploitation of resources and social inequality. It promotes unmitigated product consumption and has driven ill-considered advancements in unsustainable raw material sourcing and inequitable profit sharing that has resulted in the continued deterioration of our air, water, and soil. This is why we need circular economy to move away from the status quo and business as usual practices, because our current systems will be unable to keep pace with our growing needs, and eventually these systems will fail. Nature functions in a closed loop, with every organism and nutrient cycling back and forth to create a regenerative system. Bio-based alternatives mimic these systems to alleviate the stressors on the natural world and conserve our finite resources. We have already seen application of a bioeconomy in niche markets, one being the shift to plant-based packaging, but in order to expand the adoption, it requires the standardized holistic framework that is provided by the circular economy. As described by a member of the European Bioeconomy Alliance, we can view bioeconomies in the context of being the biological motor of the circular economy. And further, the economic viability of bioeconomies are quite substantial. The technology advances of some bio-based products and systems will make them a sustainable replacement of harmful industry practices to produce our goods and services. This essentially makes it a right economic opportunity. So as we've learned, stagnated development and innovation has slowed progress because we have yet to take these bio-based backed frameworks and apply them to our built environment. So we need to push change in the research and education sector for development and adoption of these frameworks in practice. Additionally, we understood challenges that Additionally, we understood the challenge in finding a solution that encapsulated the principles put forth by the circular economy, met the criteria of regenerative, scalable, bio-based technology, while all communicating the needs for these innovations by illustrating its feasibility as a replacement for obsolete energy, food, and production systems. And we found this with MES. So MEF is the acronym for microbial electrochemical systems, and they are an integral building block for our industries to transition into the circular economy. They are regenerative in nature in that they harness the bioactivity of microbes to produce clean regenerative energy, bioremediate wastewater, sequester carbon, and provide other holistic services to plenty of other applications. So as you can see, there are numerous types of MEF designs and constructions that can be optimized for specific needs, but we decided the best course of action was to focus our efforts on microbial fuel cells for electricity generation and storage. So in short, the basic components of a fuel cell consist of electrodes, an anode and a cathode, and electrolytes, which are the organisms. The combined MFC system facilitates electron transfer to produce clean, regenerative electricity. So you're probably wondering why we chose fuel cells. Well, outside of the fact that they generate electricity, they can also be combined with existing energy systems, which holds value when wanting to maximize the use of existing infrastructures. Also, they are able to be scaled to meet commercial energy needs. So this led us to developing our own eco-friendly fuel cell. To ensure our systems fit within the circular economy, we decided that upcycling materials was the best bet, and polystyrene was actually a practical choice because of it makes up 35% of landfills, and none of that usually gets recycled. An added benefit is that it's widely available and it offers a low cost of entry. While any type of organic substrate will channel electricity, algae has a set of distinctive qualities that separate it from every other species on the planet. From our research, we learned that algae is an essential component in clean technology. And as so, they are hardy microbes that are easy to grow. They're suitable for biodiesel conversion. They're a sustainable food source and have proven elevated carbon sequestration properties. Graphene, which is a material that offers a lot of promising applications, are already being used in a lot of commercial markets. It's relatively easy to produce without intensive laboratory knowledge. It's not toxic, and it's currently being researched in MFC development and applications because of its ability to improve electrochemical efficiencies.
And so now that leads us to biomaterials. What happens if we run out of polystyrene? Or how can we make these fuel cells better? The answer lies in cellulose, and it is the polymer, it is the plastic of the natural world, so to speak. Plastics polymer, cellulose polymer. Good thing about cellulose is that it's not bad for the environment. It doesn't require fossil fuels to make it. It's available in a massive amount in algae and in certain marine or aquatic organisms other than algae, such as salps. They are the only member of the animal kingdom that can actually produce cellulose and are available all across the shorelines. And so we decided to decellularize their carcasses and make out of that a biocomposite that we combined with graphene quantum dots and illustrated the unity that they create with it. So this validates the hypothesis that graphene and cellulose as a scaffolding and algae are a symbiotic microbial molecular environment that is capable of producing and storing electricity. Then we wanted to take it one step further and see, okay, are we able to add other particles to the mix so we can increase the efficiency of the extracellular electron transfer rate? And it turns out that we can. And this is something that needs to be explored, needs to be developed upon. It is paramount to bringing about circular economies in that we need to have these symbiotic self-generating systems for powering our everyday industrial needs. In conclusion, for this first part, key takeaways: circular economies rely on biocircular economies, biocircular economies rely on MES, and we need to incorporate best practices from modularity, microscopic imaging, doing upcycling, and advancing adoption, awareness, education, feasibility, and availability. So how do we make it more mature? Based on what we found, it requires an interdisciplinary focus and low cost of entry, constant exploration of these new applications, and establishing a common ground amongst the creators in the community and decision makers. And so, in terms of education, fuel cells offer a breeding ground for all of the required subject matter for any student, but this is specific to the engineering and humanities across the board. But they've bet to be combined with sustainable development, circular economy curriculums, which exist, and they have a project-based learning component. But what we see as the key turning point is something that combines the two. And so it's de-siloing of this experience to bring together the concept of teaching SDGs, circular economies, fuel cells, general MES experience into one with an entrepreneurial component, since our objective is to be building up a new type of economy. You need more business to make that happen. So what we see is a program that looks a bit like Silo, SDG Innovation Leadership Opportunities. So we have academic communities at the forefront of creating these new solutions, bringing them to market, and vetting them on campuses through a streamlined approach from core curriculum of understanding circular economies, bioeconomies, where certain skill sets fit in, giving the supplies and the mentorship in order to develop upon them, and a test bed on campus to validate it, and then ongoing opportunities in order to scale their solutions up. Of course, we need to be thinking about supply chain, biomimicry, ensuring that we are always generating energy, so nothing that we do is actually using up more fossil fuels, and considering the next steps of how to incorporate AI and machine learning into this, so we are becoming more efficient than we could even compute as human beings. Along the way, always having interdisciplinary collaboration. There's a bunch of different ways that microbial electrochemical systems and sustainable development goals can be fit into all the requisite subjects in the sustainability program, in STEM courses, and the humanities as well. And here's just an example of several that we have conceptualized. That said, of course, there needs to be a company to propel this forward. And that is why we, through the support of the entrepreneurial ecosystem at City College and CUNY, have created a startup that is building supplies and services to facilitate accelerating the development of bioeconomies that come in the form of, starting with the inspiration point for all of this, Star Trek and their isolinear chips. This is just a diagram of what the future holds for our microbial electrochemical system chips to be a modular design that incorporates everything that you saw earlier of all the different mess types. But how do you get people started on that? Well, you have an egg tree level and fun for experts too, kit for building biofuel cells and a biomaterial kit. So these are all cellulose-based products that are similar to saran wrap and concrete, and an online portal for all of the information tracking and on-hand microscopic imaging. What we believe to be the next best step for City College and CUNY at large is incorporating the sustainability department with the entrepreneurial ecosystem and having a common ground where the communities and motivated students, faculty can come together to create new solutions that then they can prototype and build out with our equipment, pilot these prototypes on campus, and then once they're successful, have a pathway to introduce them to communities and our city and beyond. So
to summarize, we've shown that circular economies are essential to us realizing the goals put forth by the SDGs, and bioeconomies are pretty much at the center of it. It's imperative that we prioritize collaboration among every stakeholder and utilize our current academic institutions to usher in this transition.
We can do it.
We can do it.
Okay.